Hello students, welcome back. This is video number 19 in our SmartPLS video series. In this video, we're going to discuss something really important for your maybe master thesis or PhD thesis with quantitative data analysis. We're discussing higher order models, maybe getting a bit complex using SmartPLS. However, this is really an important focus in using SmartPLS. Why higher order models? Please stay tuned. And this video will give you full details about using, manipulating, analyzing, and reporting higher order constructs relationships using SmartPLS. Before moving into application, let's just define what is higher order models. Okay, let's take, for instance, personality as one latent construct. Can we measure personality with simple indicators? I don't think that's possible. Or even not personality, maybe intelligence. Can we measure intelligence with just indicators or survey questions? That's not even possible. All right, this is a major abstraction. Okay, that's a major abstract construct in this case. Okay, and then that would be maybe the higher order construct. And then we have to divide it into further constructs. Okay, if we take personality, for instance, okay, under personality as a higher order construct or second order constructs, we will have first order or lower order constructs, like maybe introversion, extroversion, maybe any form of personality. Okay, then those second order, first order constructs or lower order constructs will be measured with indicators or survey questions. And in this case, we will have the first layer is personality. The second layer would be subtypes of personalities like introversion, extroversion, maybe narcissism, etc. And then the third layer would be the indicators that would be measuring those sub-constructs of personality. So here we are having more than one layer. And sometimes, to be a bit more complex, we may go to third order constructs, okay? Third order constructs, and then in this case, we will have first order construct, second order constructs, and the third order constructs, and all of them would be represented by indicators or survey questions. Okay, that's just an overall idea. Let's just move into application now. Please stay tuned. All right, my fellow students, and here we go, okay? All right, so let me go now into SmartPLS, maybe give you a bit of an introduction about higher order models here. Why higher order models? As I mentioned, actually, like many constructs have higher levels of instructions like personality, for instance, intelligence, maybe in our case, online banking system use, we will use perceived usefulness as a higher order construct, etc. Okay, and maybe you can refer back to the forms of relationships within SmartPLS models. We have reflective, formative, reflectives, etc. Okay, usually the literature will dictate the relationship among the variables that you choose. All right, for higher order models, the same as we do for simple models, we calculate the consistent reliability as well as the AVE, and we check for discriminant validity as well. Okay, those have to be done manually. In this video, we're going to shed detailed light on how to do them. All right, let's now go into SmartPLS. All right, let's minimize this and go into SmartPLS here. Okay, and all right, so I have here, let me try to maybe do a bit of zooming here. Okay, just shift All right. I wouldn't be allowed to zoom. All right. In this case, what we have here, all right, we have a perceived usefulness, and you know our model here, okay? You know our model. I'll just remove these latent variables, or I mean indicators. So we have a perceived usefulness, all right? This is not, if we remove those 1, 2, 3, it wouldn't be a second order construct. But however, perceived usefulness, how can we measure it? All right. We will assume that it's a second order model here now, and we will add first order constructs for measuring perceived usefulness in a reflective way. Okay. That's a reflective model in this case. So what do we have? We have the social influence. It's a one form, one manifestation of perceived usefulness. We have computer self-efficacy and we have economic benefits. All right. So these are the first order constructs. Okay, the way you understand it here, okay, suppose here we are behind, okay, sorry, we are outside the model and we're coming in. We go first into the first order construct, second into the perceived usefulness, which is the second order construct. And another term for them would be first and lower or higher order constructs. Okay. So how do we now calculate the algorithms for second order constructs, and how can we get there? CR and AVE, and check for discriminant reliability as well. Okay, it's pretty nice here. So as you see, social influence, okay, so suppose we don't have, okay, what we have to do is just add the variable, okay, and call it, rename, call it social influence, okay, influence, all right, done. All right, and here, okay, simply we connected in this way. All right, so I haven't added the indicators yet on this. All right, I haven't added the indicators yet on this. Let me add the indicators and then see how we can run the algorithms and do the calculations. Okay. All right, so if we go into annotation here, I have stamp, all right, draw text, etc. Mouse, let me see if I do mouse. All right, I wouldn't need that now. Okay, I go into mouse. Okay, just simply leave the annotation. All right, so I go into social influence. I have already the data set collected, survey questions done, data set already ready. Okay, so how can we do that? How do we add the variables? Simply we go into the social influence. Okay, click on the first, shift, click on the last. Okay, here we go. The same for the computer self-efficacy, shift, okay, computer self-efficacy. And the same is for the economic benefits, all right? I did it like this. Now, we have to know something that's very important, the repeated indicators. If we have a first order constructs here, okay, in this one, all right, I have a first order construct here in this one. Let me just draw a line here. Okay, okay, here, okay. Simply not a line, maybe a square. Okay, these are the first order constructs and these are their indicators. So what I have to do, I have to repeat those indicators in the second order construct. Otherwise, I wouldn't have the right calculations. Okay, let me just go into this one. I just want to check what did I do in this. Show indicators. Okay, see, I already put them here. Okay, imagine if I don't have them here, simply, let me hide now, just to make it look simpler. Simply, if I don't have it right here, what I do is simply go back here and then click Shift, select all of them and just move them right here. But I have them already done. Okay, so that's very simple, straightforward. Okay, let me erase this one. Okay, and let me run the calculations for this one here in this model. All right, so simply if I go select and then file, calculate PLS algorithms simply as I usually do. Okay, here we go. Okay, and I go back to the model, all right, higher order model here, okay, this one, all right, so this is the model, this is the model here. All right, I can show, if I wish to, I can simply show the indicators here, all right, so show the indicators, and simply I can see the loadings in this context, all right. So this is the way we calculate the uh, algorithms for the first order and second order models in our context. Okay, now we will move to calculating, getting the data from SmartPLS and doing the manual calculations to get the CR and AVE and check for discriminant reliability, validity as well. So please stay tuned. Super. Now let's move and show you how we can calculate the CR and AVE and check for discriminant validity for higher order constructs. Okay, let's just, move into share screen. All right. Share screen. All right. Let me see here. All right. Just to make it a bit simpler for you, I will move into, I'll just take this, all right, take this, all right, and move it into a separate just canvas here on SmartPLS, all right, and I just go into here, all right. I have already the indicators for the first order constructs, they're already in. I have the perceived usefulness should include all of them. Okay, let me check, show indicators. All right, that's it, all right. Okay, I have them. Oh no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because I took it separate here, I'll just simply remove these four. All right, because those belong to the complete model. All right, so let me hide them now. So simply, what I have here as indicators should go into here. All right, and now let's just run the algorithms. Okay, calculate PLS algorithms and start calculations. Let me see what I got here. All right, these are the standard loadings. All right, these are the standard loadings, and all of them, they look, I mean, these are the standard loadings, and the loadings, there are loadings we have, all of them look good. All right, most of them are, or all of them are above 0.6, which looks really good. All right, now, how do we calculate CR and AVE for second order constructs? Let's just, as we know, for the first order construct, and considering the measurement model here, it's simply calculated by SmartPLS. We have already done videos about those, all right? And you can simply go back to the proper video and just follow up the details right there. Now, I prepared simple sheet here on Excel sheet, an Excel sheet here. Okay, so simply what we take first, that's standard loadings, all right? Okay, let me just remove those, total loading squared, let me remove those. Okay, standard loadings and then standard loading squared. Let me go with the standard loadings. Social influence here. Okay, social influence, the standard loading is 0. Here it is, all right? No, this is the standard loading, here it is. Okay, we read it here on the arrows. Okay, so for the social influence, it is 0.906, 0.903 for economic, 0.948. 0.906, and I have for economic benefits 903, all right, 0.903, and I have 0.948 for the computer self-efficacy. Okay, 948, here we go. Then now I have the standard loading. Standard loading square equals to this. Okay, let me just square it. Shift, no, shift, no, shift, even now, shift even now. No. All right. Where do I find that shift? Okay, here it is. Square. All right. So simply I square those. Okay, and simply drag the cell in. All right, then error variance, how do we calculate it? It's equal to 1 minus standard loading squared. Simple. Here we go. Okay, so step by step, first we get the standard loading from SmartPLS right here on these arrows. I go into standard loading squared and then error variance. Then I get the sum, total loadings. Okay, simply just sum it. All right, so home, simply sum it. Okay, here we go. Sum it and simply drag. Okay, I get the sum of them. Then total loading squared. Total loading squared. So this is the standard loadings. This is the total loading. Let me square it. So it will be equal to this and then shift. Okay, shift here. Where did I find this in a bit now? Here it is. And 2. All right. This is the total loading squared. Okay. So now, just continuing, just to get all the figures that I need from which I can get AVE and CR for my second order constructs. Okay. I wouldn't worry about the first order constructs because it's already calculated. Like this is the AVE for the first order construct. Okay. This is the first order construct. This is the AVE. However, I need the second order constructs, and this is usually calculated manually. I wouldn't worry about the figure given by SmartPLS because it wouldn't be the right figure. Okay, I have to calculate this manually. All right, then total error variance plus total error variance equals to total error variance. Here is the total error variance plus total loading squared. This is the total loading squared. Here we go. Okay, total error variance. Okay, plus the total loading squared. Okay, total error variance plus the total loading squared. That's equal to 3. AVE is equal to total loading divided by the number of constructs equals to total loading divided by the number of constructs, first order constructs, 1, 2, 3, simply by 3. 0.990, which is really good. Anything that's above 0.6, okay, according to, I will just cite something here. All right, Farker et al. Or something like that. I'll just check this for you. All right, it's equal to 0.919, which is above 0.6, which is good. How about the CR? Total loading squared divided by total error variance plus the total loading squared, which is equal here, okay, equals to total loading squared, which is this one, divided by the total error variance plus total loading squared, which is this one, all right, 0.844. This is the CR, all right? So this is actually the way we calculate the AVE as well as the CR for the second order construct. Okay, so now this is for AVE and CR. How do we check for discriminant validity of this kind of constructs or second order models? Please stay tuned. All right, let's see now how we can report the CR and the AVE that we calculated for the second order constructs, okay? All right. Share screen here. All right, then, all right. Okay, so I have here the data. I already calculated my AVE, my CR, reporting them. How do I report them? Simply, I have this table. I have prepared it already for you. We split it into 2. As you notice here, this is, let me just color it, all right, a bit of coloration. This is into maybe yellow, and the other one just keep it not colored. This side, the right side of which is the first order construct. Simply, I put the items. Those are the indicators, loadings, and I take the loadings. How do you get those? Very simple, okay? Simply, here they are, okay? So for here, I have the computer self-efficacy. Okay, here they are. All right. I put them here. I have the RHO, CR, and AVE. This is the AVE. RHO, I simply can get it right here, see? And what's more here, the CR, okay? The CR composite reliability, here it is. Okay, simply I move them. So I have no problem for this first order construct. Let me just make myself a bit bigger. I have no problem for the first order construct. How do I report the second order? Now it's simple. I simply go here. And what I need to report simply is the AVE and the CR. Okay, so if I go into this one, second order construct, what do I have? I have the usefulness, okay? The usefulness here, the perceived usefulness. Okay, the CR is right here, is 0.844 or 0.845.919. So 0.919 and the 0.845. This is for the CR and this is for the AVE. All right, let's just now check the discriminant validity for higher order models. I wouldn't do anything manual for sure, but I can go into SmartPLS. I did run my algorithms. Okay, I go into algorithm and check validity here. What I have to look here for simply would be, did I write any notes here for you? No. Maybe I'll check if I did write any notes in a bit. Okay. So simply here, I go into perceived usefulness, all right, perceived usefulness, and I simply focus on this, okay, 0.787, all right? So this is the perceived usefulness, discriminant validity. I take the HEA cross-loadings, okay, cross-loadings. This is Fornell and Larker criterion. Okay, perceived yes, usefulness 0.787, okay? I want to check if I left any notes for you in this file or in another file. Okay, it doesn't seem I have left any notes right here, maybe here. Okay, not even in this one. All right, discriminant, okay, here it is, okay? Simply, I left the notes for you here. So note, report only large constructs, okay? So in discriminant validity, I report only the large construct, which is the perceived usefulness in our case, okay? Bolded diagonals represent square root of AVE, while off diagonals represent the correlation. And Forner and Larker criterion 19 diagonals values must be higher than rows and columns. That's how we can differentiate them. All right, my fellow students. So in this video, as you have noticed, I've shown you how to calculate the algorithms for second order constructs, as well as reporting these results. Okay, so let me just share screen and do some wrap up here. So simply here, the results that I got in Excel, I simply can copy them into maybe Word, into my article, simply just copy them into Word, whatever article that you've got, okay, so, and simply name it maybe here, okay, and you can just title the table, okay? So that's how we report them. Let me just go back to my PowerPoint here and see if I missed anything. All right, so, okay, we have defined higher order models, differentiate between first order constructs and second order constructs, okay? And we have advised about the types of such models, maybe reflective, formative, etc. We checked the literature to know how to differentiate them. We have calculated AVE and CR manually, and we have checked discriminant validity simply by choosing the larger constructs from the PLS algorithms. Okay, repeated indicators. In the repeated indicators, we have shed light on the importance of having all these indicators inside the main or the father construct. Let me call them those sons, and this is the father construct. So whatever you have for the sons here as indicators has to go into the father constructs. Okay, I have done those. This is the repeated indicators approach. Okay, the two-stage approach, I'll leave it for the coming video number 20 in our video series. In video number 20, fellow students, we are going to discuss something a bit higher of complexity, and this is the third order constructs. We will have a model where we have first, second, and third order constructs, and I'm going to shed light on the two-stage approach of PLS algorithms. Okay, so Dr. Ayub here from SRDI, Smart Research and Data Analytics. Please like this video and share it across to students, and subscribe to my channel. Hit the ring bell, or hit the bell icon to receive any new notifications. And please stay tuned for the coming video. If you need to contact me, you can simply WhatsApp me for any consultancy or any further explanations pertaining my videos in this video series. Thank you for watching, and please stay tuned for video number 20. Bye-bye for now.